Hey students, how are you all? I hope you are quite very much excited to know what you are going to learn today. Okay, so today we are going to clarify a little bit more what we have studied earlier. Remember this figure? I hope you remember. This figure was representing how refraction occurs in a glass prism, right? So this was the incident ray, this is the emergent ray, and this was known as the angle of deviation. I hope you remember. If you don't, you can again go back to the that video refraction prism, and you can see how it occurred. So today we are going to see how does refraction occurs, and is refraction the only phenomenon occurring in the prism? Come on, let's see. Okay, now since we are studying a little bit about light, now let's study a little bit in dark. I guess you might not be able to see many things here, but you can see a white color screen, there's a duster, and this is a light source, and this is a prism. Now see, when I'm putting light on the duster, you can see it, right? It's in a straight line. If I make the light to pass through the prism, what happens? Okay, the light wouldn't go straight, right? Let's see how it refracts. Okay, see. Now when I'm making the light to pass through the prism, the image or the light, instead of forming on the duster, it is forming on this white screen. Okay, so what is happening here? Here the light ray is bending. This phenomenon is called as diffraction. Understood? You can see it again. Now the light is on duster. Slowly when we tend to just slide the light ray towards the prism, you see the light ray now it is forming on the screen, on the white part. This is refraction. Understood? Now the question is, does only refraction occurs in case of prism? Stay tuned for the next one. Okay, so now in the next experiment we have replaced that kind of a laser light with this torch light. Okay, now we have the same prism. You can see that the light has a spot, makes a spot here, but if you pay close attention to this part, okay, this is the part where the refracted light is being formed. And if you see clearly, if you see a little bit more attention, if you pay more attention, you can see some colors is formed. You can see a little bit of blue color in that. Wait, let me help you. Okay, so what you saw? In this case, you might see some colors, and in the other image also, you saw that in case of the torch light, what you are using, you could see some colors, right? So where do these colors come from? These colors, they are quite similar to that of rainbow. So where do this color comes from? So this phenomenon is known as dispersion. Okay. So the things what you saw just before explains that in a light some colors are hidden inside, right? Just like latent heat, there's a latent colors, and the same things can be said for sunlight also. In sunlight also, these colors are hidden, and this can be extracted using the same phenomenon by using a prism. Sunlight can also be broken down into different colors, just like the colors of a rainbow. This phenomenon was discovered by Sir Isaac Newton, and this phenomenon is called as dispersion. So what you can say is the scattering of light into its constituent colors is called as dispersion. Okay, so dispersion can be defined as the scattering of white light into its constituent colors. So now Newton, while studying more about refraction, he accidentally kept the window open, or somehow the sunlight came inside, and in the prism, near to the prism, the rainbow colors were formed. So at that time he realized that the light has been divided into this constituent colors. To know more whether light contains these 7 colors or more, he kept another prism. But then he realized that sunlight has only 7 colors. Okay, so what actually happens in this case, as we studied, the light, it deviates when it enters inside a prism, right? So different colors of light has different wavelength. In a rainbow, as you can see, in rainbow there are generally 7 colors, right? What are they? Violet, indigo, blue, green, yellow, orange, and red. Right? These are the 7 colors in the rainbow. So these 7 colors, they have 7 different wavelengths. Okay? Every different color has a different wavelength. And generally, what happens when this color, when they strike to the reflecting surface, since they have different wavelength, the speed gets changed. As your speed of a light also depends upon the wavelength. So change in wavelength results in the change in speed of light, and we know that refraction occurs due to change in speed of light. So since these different colors have different wavelength, so they deviate at different angles. Let me make it clear. If suppose this is the sunlight, so when it enters inside, what happens? Okay, it is made up of 7 colors, and these 7 have different wavelength. Highest wavelength is of red and lowest is of violet. Now this deviation angle, okay, the angle of deviation D, it depends inversely on the wavelength. If the wavelength is more, the deviation will be less. If the wavelength is less, the deviation will be more. So what happens? So due to this reason, whenever sunlight falls on a prism, it breaks down into 7 constituent colors. Okay. Okay, so 7 different band is formed. Okay, in the lowest part, violet is formed, and in the highest part, red color is formed. The reason is because violet, since its wavelength is less, its deviation angle is more, means it deviates more. And red, since its wavelength is more, its deviation angle is less. It does not bend so much. So that's why it is formed on the top and violet on the bottom. This phenomenon is called dispersion, and when it occurs in nature, okay, then rainbow forms. So you might recall that rainbow generally forms whenever there is a sunlight after a rain shower. Okay, after the rain, if there is a certain bright sunlight, rainbow is generally seen. So the question is, how does it form? What happens in nature? The water droplets present in the atmosphere. Okay, if you consider this water droplets which are present in the atmosphere, they act as a prism. So the sunlight falling on that water droplet, they undergo this dispersal, and due to which they bend at different angles and form the constituent colors. Okay, this is how rainbow forms in the atmosphere. Okay, in the atmosphere, the water droplets, they act as a prism and cause the effect of dispersal, and due to which rainbow is formed. Understood? The next thing is atmospheric refraction. Before moving on to atmospheric refraction, please make a small correction. Okay, dispersion. The definition of dispersion is the splitting of white light into its constituent colors. Okay, this is the actual definition for dispersion. The splitting. Okay, not scattering. Scattering of light is something which we will study later. Okay, this is splitting of light into its constituent colors. Now, like I said, dispersion isn't the only phenomenon occurring around us. One more such phenomenon is atmospheric refraction. Now, what is atmospheric refraction? Simple. Okay, the refraction occurring in our atmosphere. the refraction occurring in our atmosphere is generally called as atmospheric refraction. But now there's a question, is that refraction generally occurs when there is a changing medium. But if we're talking about our atmosphere, where there is where is a change in the medium? So there is no change in the medium, right? If it is in the atmosphere, well, there is. So remember, the light to Earth comes from the sun, right? Now, when it is coming from the sun, it is coming from vacuum. Since light is an electromagnetic wave, it can travel in vacuum. So light is coming to Earth from vacuum into the Earth, and when it enters the Earth, it actually enters into the Earth's atmosphere. Although the refractive index of atmosphere is nearly negligible, but still it has some amount of refractive index. So that's why there is a change in the medium. So what actually happens when light comes from space into the atmosphere, it is actually coming from a rarer medium into a denser medium. So due to which diffraction is taking place, and due to that we are seeing various activities, just like twinkling of stars. At night, if you see the night sky, you can see stars twinkling. This occurs due to atmospheric refraction. Then advanced sunrise and delayed sunset. Okay, let me ask you, how many of you have seen sunrise? Most of you might have seen a sunset, but how many of you have seen the sunrise? Okay, I guess some of you must have seen. But what if I tell you that wasn't the actual sunrise what you have seen, or that but the sunset what you have seen is not the actual one, rather a late one? So this will study again. And the next phenomenon, next thing which occurs due to atmospheric refraction is mirage formation. Okay, now let's know what are all these things: twinkling of stars, advanced sunrise and delayed sunset, mirage formation. First is twinkling of stars. Now, at night sky, at night when you see at the sky, you see most of the stars they twinkle, right? Flicker. They twinkle. They go, they glow, and then again, what you can say, they go very much dull. Then again, they bright. Twinkling effect is seen. Have you ever wondered why this twinkling occurs? Well, a small boy once he wondered, and he wrote a poem, "Twinkling, twinkling, twinkle, twinkle, little stars." Okay, we are not going into the poem, but the question is why the twinkling is going on, right? So, twinkling of stars actually occurs due to atmospheric refraction. Suppose this is the surface of Earth, okay? This is the Earth's surface, and this is our atmosphere. This area is our atmosphere. So generally, if you take the sun, the light from the star is coming through this way. This is the path of light coming into it. Let me make it a little bit clear. I hope all of you might remember the poem "Twinkle, Twinkle, Little Star, How I Wonder What You Are." Okay, but after learning this, we don't need to wonder why the stars twinkle, because we already know what are stars, right? Now, suppose here is the star. Now, the light coming from the star, it travels from the vacuum, then it enters into Earth. This is the atmosphere. Now, when it is entering into the atmosphere, it is actually entering from a rarer medium into a denser medium. So, what happens? So, due to which it undergoes diffraction, and instead of, if we take this as the normal, instead of going this way, it bends, right? It bends and here. So, this person, the person staying here in this region, he will see this star, okay, to be as light current here. So, the star is actually here, but due to atmospheric refraction, we are seeing the apparent position of the star due to atmospheric refraction, right? But the question now, the twinkling, why it happens? So you see, our atmosphere is not a constant thing. It is moving. It is a mixture of gases, different gases. So generally the gases are always in a random movement, random motion. So due to which there is a constant change in the atmosphere. sometimes there is a gap due to which we see a bright light, and sometimes there is completely crowded, more gases, so we see a dull light. So this continuous changes causes an effect known as wavering. You might have seen when in a place, if a fire is burning, just before the fire, just on top of the fire, you can see the image which is there, it will be blurred. Why? Because the air there is continuously changing, right? So this phenomenon is called wavering, and this phenomenon is occurring here also. Due to continuous change in the atmosphere, the light coming from the star sometimes becomes bright and sometimes becomes dull. This continuous brightening and dulling is the twinkling effect of the star. So understood why stars twinkle? Good. Now moving on to the next one, that advanced sunrise and delayed sunset. How, due to atmospheric refraction, advanced sunrise and delayed sunset is occurring. Suppose this is our Earth. Okay, our Earth is not spherical, so I made it like this. Okay, so suppose this is the Earth and this is the layer of atmosphere around the Earth. Now, suppose we will consider for this position, person living on this. If the person is staying here, then this is his horizon. This is the region of its horizon. So the person can only see the light ray, the person can only see the sun when it is above the horizon, that is the sunrise. So what happens here, when the sun is just below the horizon, if here is the sun, okay, if this we take as the position of the sun, when the sun is just below the horizon, then the light ray, that is the light ray that is coming into the earth from the sun, generally when it enters into the atmosphere, if this is the sun and this is the light ray coming from the sun, when it enters into the earth's atmosphere, it undergoes refraction and it bends. Due to this bending, the sun appears in this way. So let me make it a little bit more clear. Okay, so this is the horizon. Okay, we'll take when the sun is below the horizon. Now, when the light is coming from this, the light ray is going like this. This is the light ray, right? Coming from this one. Now we'll consider this ray. Okay? When it is entering into the Earth's atmosphere, it will undergo refraction, and due to refraction, it will bend. And this bending, okay, will reach to the observer. So since the light, our brain considers light to travel in a straight line, our observer thinks the light is coming from a straight path. So it will imagine that here. Okay? It will consider that the light is coming in a straight line. So here it will consider the sun is, okay, the sun is just about to rise. Okay, so what happens? That due to atmospheric refraction, okay, when the sun is just below the atmosphere, the light ray it deviates, the light ray it's bent. Okay, and when it reaches to the observer, so the observer considers, or the eye of the observer forms an image, an apparent image of the sun just near to the horizon, considering as a sunrise. So this phenomenon is called as advanced sunrise. Similarly, in this case, if suppose this is the horizon, okay, this is the region of the horizon. So when the sun has already set, that means it has gone below the horizon. In this case also, when the sun has already gone set, in this case, okay, the light ray, what happens when it enters into the atmosphere? It bends. Okay, so making the observer to believe the sun is still above the horizon. Okay, so in this case what happens, the sun actually has gone below the horizon, but due to refraction we are seeing an image of the sun above the horizon due to atmospheric refraction. This is called delayed sunset, and the gap between this is 2 minutes, and here also this gap is also 2 minutes. So the actual sunrise occurs after the apparent sunrise. What sunrise? The sunrise what you are seeing, 2 minutes after that actual sunrise occurs. And when we see the sunset, okay, before 2 minutes only sunset has already finished. So this phenomena occurs due to atmospheric refraction. Now let's move to the next one. Last but not the least, one more thing that occurs in nature due to atmospheric refraction is mirage. Now what is mirage? Mirage is generally, you might have heard from some people or might have seen in television, generally in a desert area, when there is when it becomes very much hot, then people see that in a place water is stored, right? But when they reach there, there isn't any water. You also might have witnessed that when you are traveling during noon time, okay, when there is quite bright sunlight in the noon time, you are traveling on the road, at some distance you will see that on road there is water might be present. It will look like that at a distance on road there is water, but when you reach there isn't any water. This thing is called as mirage. So why this happens? Mirage actually occurs due to atmospheric refraction. Now, in this case, the light is not, means here we won't consider light coming from the vacuum or from space. So what happens? That due to increase in temperature of the land, the air just above the land becomes more hot as compared to air above it. So there is a temperature difference between the air. So due to this temperature difference, the hotter air becomes a rarer medium and the denser air, the cooler air becomes a denser medium. Suppose if this is the land, due to more hot, the air which is present near to the land, this acts as a rarer medium, and the air which is just present a little bit above acts as a denser medium. So the light, when it moves from one medium to other, it refracts. So what happens if a tree is there, if something is there, a tree or something, if there is a tree, okay, it forms its image here. Okay, due to this atmospheric refraction, we see the image of the tree is formed on the ground. So our brain considers there is a water body is present here, and we are seeing its reflection in the water body. So it misunderstands that there is a water here. This kind of mirage is called as inferior mirage. Inferior mirage. Now this is not the only mirage that occurs, or it is not a mirage only occurs in hotter region. In case of colder region also, there is a different kind of mirage which occurs. So generally what happens in a colder region, when the air just above the land becomes more cold as compared to near to the land, right? Just the opposite one. In colder regions, in colder areas, okay, generally what happens, okay, if this is the land, the area just above the land is generally hot one, right? But in this case, just the opposite happens. What is that? In this case, the colder region, it becomes a cold one, okay, and the air above it remains hot due to presence of sunlight or continuous falling of sunlight. So due to this, the lower area acts as a denser medium and the upper area acts as a rarer medium. Okay, due to this change, there is a change in the mirage formation also. In this case, what happens? If suppose there is a mountain here, if there is a mountain, the peak of the mountain, if there is a lot of clouds, little bit of foggy climate forms, then the peak of the mountain appears little bit higher in this position. Okay, this kind of mirage is called as superior mirage. Okay, so this is the two different types of mirage forms due to atmospheric refraction. Okay, let me tell you once again. Inferior mirage generally occurs in hotter areas. Okay, because of it. Why it happens? Because in hotter region, due to increasing temperature, the air near to the land becomes more hot, okay, than the air above it. So it acts as a rarer medium, and the top air acts as a denser medium. So it forms an inferior mirage. In colder areas, the air above the land generally becomes cold, and the top air is hot. So it acts as a rarer medium, and the air near to the land acts as a denser medium. So it forms a superior mirror. So these are the things that's happening around us due to atmospheric refraction. So this is for now. Have a nice day.